All right, let's dive into something that's absolutely critical, but honestly often gets overlooked in the machine learning lifecycle, the actual infrastructure that our models run on. Especially for any data scientist who's looking to make that leap into an ML engineering role, you've got to understand this stuff.
So you know the feeling, right? You've spent weeks, maybe months, perfecting your model's logic. The code is clean, your accuracy is amazing, but then you push it to production and it just fails. Or maybe you get that cloud bill at the end of the month and it is shockingly high. Why does this happen? Well, it's because for so many of us, the hardware our code is running on is a total mystery. It's this unpredictable black box that leads to surprise failures and, yep, those runaway costs.
The solution, the way we fix this, is with infrastructure monitoring. Think of it as shining a huge spotlight into that black box. It's really just the practice of continuously tracking your hardware resources, your CPU, your memory, and especially those super expensive GPUs, so you can see exactly what they're doing while your code is actually running.
Okay, so how do we actually get that visibility and control? Well, monitoring essentially gives you a dashboard for your hardware. It's what turns all that guesswork about costs and performance into concrete, actionable knowledge.
When you do this right, you get 4 huge benefits. First up, cost control. You can finally spot that expensive GPU that's just sitting idle for hours and, shut it down. Second, performance optimization. You can find the exact hardware bottleneck that's making your training loop so slow. Third is reliability. This is a big one. You can catch a memory leak before it crashes your 12-hour training job. And finally, you get the data you need to make really smart decisions about how to scale your infrastructure in the future.
So, if monitoring gives us this awesome dashboard, what are the most important gauges that you need to be watching? What really matters?
Okay, here are the absolute core metrics. First, CPU utilization. Is your CPU constantly maxed out? That's a huge signal that maybe your data preprocessing is the real bottleneck, not your model training. See your memory usage creeping up and up? That is your early warning sign before a catastrophic crash. And my personal favorite, GPU utilization. If you see that this number is low while you're training, it means your code isn't actually taking full advantage of that incredibly expensive hardware. You are literally burning money. Watching these gauges tells the real story of how your code is interacting with the machine it's running on.
All right, this all sounds great, but it also might sound complicated. How do you actually start? Well, the good news is if you're already using MLflow, you can get a basic dashboard up and running with almost zero effort.
And when I say almost zero effort, I'm not kidding. This is it. This one single line of configuration is your entry ticket. Just by adding log_system metrics equals true to your MLflow setup, you automatically turn on hardware monitoring for your job. It is that simple.
The whole process is really just 3 simple steps. Step 1, you enable that setting in your job's run config. Step 2, you just run your job exactly like you always do. MLflow handles all the logging for you in the background. And step 3, you just pop over to the MLflow UI and boom, right there, linked to your specific run, you'll see beautiful charts showing your CPU usage, memory, and more over time.
And for those of you who want a little more control, MLflow lets you customize things. You can change how often it collects the data, you can pick and choose only the specific metrics you care about, and you can even export all this data to more advanced tools if you want to. Now let's be clear. MLflow is absolutely perfect for analyzing individual experiments. But once you start moving into a full-scale, 24/7 production environment, you're going to need to upgrade your toolkit to more powerful, dedicated platforms. The first tool you absolutely have to know in the pro world is Prometheus. It's the open-source industry standard for collecting metrics. The way it works is pretty cool. It basically pulls data from all your services, kind of like a supervisor who's constantly walking around asking each component for a quick status report. But here's the thing about Prometheus. It just collects the data. It's not pretty to look at. To actually see all that useful information, you need Grafana. Grafana is the go-to open-source tool for visualization. It connects to Prometheus and lets you build those powerful, beautiful dashboards that give you a complete view of your entire system's health. Now, if setting up and managing a Prometheus and Grafana stack sounds like a lot of work, well, it can be. That's why there are commercial options, and a leader in this space is Datadog. It's a managed, all-in-one platform that handles everything for you. The choice really comes down to control versus convenience. Prometheus gives you endless customization, while Datadog gives you incredible power right out of the box.
So, let's bring this all back home. The whole goal here is transformation. Effective monitoring takes your infrastructure from being that scary, unpredictable black box and turns it into a transparent, predictable, and highly optimized asset, one that actually helps you build better models faster.
I'll leave you with this one final thought. As data scientists, we obsess over tuning our models' hyperparameters, right? We tweak learning rates and layer sizes to squeeze out every last bit of performance. So the question is, are you giving that same level of attention to tuning the hardware it runs on? Because that's where the next big gains are just waiting to be found.